Hi everyone, this is Mr. Baragon again here. So, first week went by, and everybody at this point has either signed in or gotten news or has reached out to me. And with a few exceptions, I think most of you guys have attempted to start the assignments. I'm still trying to reach out to a lot of you, but I think almost everybody has already. So we're gonna go on to day three assignment. This is for the CPM. If you're doing the Delta Math, you already know the schedule for that. Can you guys start a new? Oops, I went over there a little too far to the right. Can you guys start a new page in your notebook? Use Cornell Notes. Here's your title for 1-2. How can I use a graph to solve? So we're looking at solving equations, right? We're using a graph. So let's go down to the problem we're going to look at. So today's problem starts here, 419. So on this first video, I'm going to focus on just this problem, and then I'll make another video for the next problem. It says Karen cannot find out how to solve 20x plus 1 equals 3 to the x algebraically. So she decided to use her graphing calculator. However, she finished entering the equation y equals 20x plus 1 and y equals 3 to the x power. She got a graph to the right. After studying the graph, Karen suspects there's no solutions to the equation given. Okay, so what are we doing today? So let's look at each of these sections. So part A is asking you, what do you think? Is there a solution, right? Or are there no solution? So I need you guys to give me a reaction. Think about everything we've studied so far up to this point. Do you think that there's a solution if this is what the calculator is giving her? Okay. What do I mean by solution, right? So that's a good point. So when I'm looking at two equations, right, we have two different equations and they're going to give you two different graphs. So what do I mean by the actual solution? So let's take a look at part B. It says, what should the solutions to the equation, this one given here, look like? So what are we referring to? When I'm looking at graphs, you guys, and these graphs are being formed by, are being created by the equations that we have here. What do I mean by a solution? It says, in other words, will the solution be a single number or should they be coordinates of a point? Explain. Okay. So think back, you guys. Where have we seen this? Where we have seen more than one equation graphed? And what do I mean by the solution? Okay, so think back to your notes, look back at your old notes. What do I mean by that solution? And I need you guys to answer both part A and B. So up to this point, it's not necessarily the mathematics that we're looking at in terms of calculations. I just need you guys to think about what's going on here in this picture up here, right? All right. So you guys should respond to these two questions. Now let's move on to the next part, part C. It says, Elena started first by subtracting, to solve first by subtracting one on both sides of the equation. When she graphed her system later, she used the equations y equals 20x and y equals 3 to the x power minus 1. Should she get the same solution? Test your conclusion with your graphing calculator. Okay. So what they're asking here is, well, if we change the equation in this manner, what's the solution then? Will it be different from the answer we gave back here in part B? So it's asking you for a graphing calculator. Well, we're gonna use the same graphing calculator that we used before, and we're gonna graph these two equations. Okay. So here it is, y equals 20 to the x, right? And we've done this before. And then we're gonna do the other equation, y equals 3 to the x power and minus 1, right? That's 1. Okay. Those are the two equations. And they're asking, should they get the same solution? So whatever you guys answer for part B, you're comparing it to part C. Okay. And you should be using the equation. I mean, you should be using the graph that we just concluded here. It says, discuss with your team whether you could solve the equation algebraically. What do you think? So most of this problem, you guys, it's about you guys thinking about your solution and thinking about what the solution should look like for these two equations. Okay. I'll leave it with that. You guys leave me any messages if you have any questions. Okay. Good luck.